This iPad and I are about to come to blows. I was talking away and realized that the thing had cut me off. Sorry. Let's think about math on page 65. How many ways can 5 different positions be filled by 10 applicants? Okay, this is a permutation. So let me draw a little bit bigger variable box. I'm going to add a little bit of information here. So we have P, little n, and little k. All right. P is the number of outcomes. So this is the one that we don't know yet. N is going to be the number of applicants. How many people applied to this job? And K is the number of positions. And let's go back up here just a second to this city council one. And that was also the case. N was the number of members. K was the number of positions. And P, capital P, was the number of possibilities, or the number of combinations. So that same pattern is holding through all of these. If you look back at this one that we did, the competitors, that was the number of competitors. The K was the number of positions that mattered, and then P was the number of combinations to finish. So it's that same sort of pattern over and over. All right, so let's set up a, I'm going to move this in here. I was going to leave it out there, but let's go ahead and put it in there. All right, so here we go. Number 1, it says, how many ways can 5 different positions be filled by 10 applicants? So the formula, I know it's ugly. It's when I did it again. I did this back in college. When you know n and k, your formula will be n factorial over n minus k factorial. So we're going to say, okay, n is 10 and k is 5. So n is 10 factorial and k is 5. So we have permutations equal 10 shift 3. It's big. But if you notice, we keep getting that over and over. 10 factorial will always be that number. And on the bottom is 5 factorial. You may remember that it is 120. So let's do all clear. 3628800 divided by 120 is 30,240 different permutations, different possibilities for the order of those applicants. So I like answer C on that one. And then here comes number 2. And I'm going to just make a copy of this. So we have, the numbers will change this time. So we'll take 10 out and 5 out and see what we have. Which represents the number of ways to order 6 people in line? Well, we have 6 positions and we have 6 people. And we're looking for the number of outcomes. So we will have P of 6 and 6 equals 6 factorial over 6 minus 6 factorial and that's going to give me an error because 6 minus 6 is 0 and you factorial, oh, it's 1. That's right. Okay. But this is not even what they're looking for. They're looking for this part. So this will, I'm going to finish it for you, but I like answer B on this one. So let's go ahead and work this out, even though we don't have to. Do 6 factorial, so you have all clear. 6 shift 3 is 720. And then 6 minus 6 is 0 factorial. So all clear, 0 shift 3 is 1. So there are 720 ways to put those people in line. And again, the answer was not 720. It's the setup, which represents the number of ways. So they want to know the actual notation for the permutation. Now, I do want to do that core practice problem. Let's see what it is before I try to write it down here. And I'm hoping I can fit it in right here, but we'll see. So this is still page 65 on the core practice. If I can't fit it in here, I'll move it to the next page. I haven't read it yet, so I don't know. This is called Model with Mathematics. Sometimes it is helpful to use a formula to model a mathematical process, such as counting possible permutations. And that's what they're talking about right here. That formula is going to help you on any of these problems. There are 12 students enrolled in an advanced sculpture class. For their semester project, all students enter one sample of their work in a juried exhibit. The jury of professional artists awards 1 gold, 1 silver, and 1 bronze medal. How many different ways can the awards be distributed among the students? Well, we have 12 applicants. There are 3 positions, gold, silver, and bronze, to be filled. So this formula is going to help me here. I'm going to say permutations when n is 12 and k is 3 will equal 12 factorial over 12 minus 3 factorial. So let's do 12 factorial. It's going to be huge. We can already know that. Oh my goodness. 479001600. So that's what? 479 billion 1,600. No, 479 million 1,600. Excuse me. And then 12 minus 3 is 9 factorial is 362,880. So very carefully, let's type that in. 479001600 minus 362,880 is not what I got. So let me try again. Divided by 362,880. is 1320. So there are 1,320 different ways that the awards could be distributed. All right, I'm going to stop this video and I'll see you in the next one.